Today on Untitled Chapter, I'm going to be looking at this Casio projector, and it's one of the slim projectors. This came from my friends at Laser Fusion. So, Laserists, a while ago, years ago, got these projectors because inside they had a bank of laser diodes. And it was at the time where the blue laser diodes were really expensive still on the market. And it's actually cheaper for the people to buy the projector and pull the lasers out of it. So, since it came from a projector that was bought and used for that application, it doesn't have the blue laser system in it, so the whole laser array is missing. Now, I've tried to power this up already, and it seems to have the thermal system on the actual laser bar arrangement, and without that thermal system, it seems to be 2 or 3 thermal sensors. It's hard to tell from some of the pictures, but they connect here, so you got your laser inputs and then your sensor inputs. So right now this thing won't boot completely because it has a lamp warning, thermal warning, whatnot, because the thing said there's nothing in there. That's absolutely right, it's missing some pieces. So my first objective is to kind of pull this apart and see what's inside, see if I can figure out exactly what the sensor wiring is, maybe trick those sensors and get it running. The other thing is once I get open, get this open, and once I get into it, I want to get to the DLP core, and that's pretty much my goal. I want a DLP chip that I can mess around with and use for various prototyping applications. And I've tried this before, got this, that didn't work too much. A great way to blow up a HDMI port on your computer. Tried this as well. Let's crack this open, and looks like there's some case screws on the outside, so I'm going to get to those first. There's going to be some good stuff in this video, I guarantee you. Okay. Get off you. Okay, looks like we got the ZIF connector for the top buttons. Okay, let's get this disconnected. Let's take a look and see if we can locate the other thermal sensor units, some of the other optical output components like the red LED. Okay, looking at this, we should have both the red and the green light source in here if only the blue is taken out. So I'm guessing this is going to be one of them. Where the other one is right now eludes me. I'm okay with that. A little bit of a mystery for me. Looks like we got the power supply here for everything. Makes perfect sense. Okay. It's a nice little cleanly built unit. And let's see if we can take this guard off. Where's that held on by? Looks like it'll be all around. It's saying no, not yet. I want to give you my secrets. So this is where we start playing the Get Lucky, hopefully, game, and figure out if we can use that high level input, that 5-volt input, to pull up whatever sensor needs to be pulled up to trick this into running. I'm going to put power back into the system and see if applying that same 5-volt reference to one of the probably the ins will enable, or they'll enable. We can't go wrong, right? I mean, it's either going to turn on or it's not. Yeah. I'll be feeling lucky. V500, what does it even mean? Yeah, I know, blink, blink, blink. Okay, well, it did something different. It's not a bad step in the directions I want to go in. Okay. Off already! Yes. Ridiculous. Where the hell is that cap? You can't wait for that every time. Are you kidding me? Okay, I've got myself another test wire with another pair of 470 ohm resistors. I've got that one that I've already found jumpered off, which seemed to have do something, so something got enabled. I want to see if I can find another circuit of which to enable. That'll be the same method. Onto the next one. Nope. Now you gotta wait forever. Okay, so the truth of the matter is, I really have to get into the boonies of things, so I'm gonna have to remove the power supply to figure out what the pinout of that rail system is for the sensors. It looks like there's a listing on there. I want to try to read. Oh, that is a nice transformer. So I'm guessing that each one of these test points right here is going to have an independent variable on it. And there's 5 of them corresponding with the 5 connections. So done all the test wires, and now I've got knots to figure out what everything is. Figured out that wire 2 is ground. So, still a little bit thrown off here. Haven't really gotten anything to run quite yet, but I figured, you know, get a little break in and maybe remove some of the bits that I know I don't need and show you a little bit about some of those bits that are going on. After many hours of research on both the DLP-A and DLP-C chip, I realized there's a lot of serial protocols to handle, and it's not something that I can do very well. So I'll be walking you through the rest of the projector components and telling you a little bit about how they work in the rest of the video. Pull the color wheel, do that out and show you what this is all about. Okay. On a normal DLP projector, the one that isn't using laser, you have a color wheel that is a red, green, and blue, sometimes with a white, sometimes other colors on the color wheel. It's kind of a little bit of weird color wheel here. So you have the red that comes in and is modulated with a digital signal, and you have this color wheel right here, this wheel, and there is a clear portion in here. And then you have a phosphorus coating along the outside. And that phosphorus coating glows underneath the blue laser when it gets hit, which is where the green light ends up coming from. Let me go get a black light. Yeah. So, check this out. Turn off the light. And so if I do that, see how that ring glows. So, when the laser light comes in, it either turns into green light, or is the blue that goes through. The red LED assembly. Let's see. Is there a sensor on here? Oh, sensor. No. Oh, okay. That's for a thermoelectric junction? Yeah? God, maybe that is a thermoelectric junction in there. Not what I was expecting. It's just kind of loose in there. Oh, well. Definitely not expecting it to be loose. It's like, oh, I see. It's held on by a couple of brackets on the back. Okay, yeah. So that is, yeah, there's got to be a Peltier junction in the middle of that right here to cool down the LED. It looks like a sealed Peltier junction. Here's this arrangement. You'll notice on the inside that there are a bunch of these mirrors, and if I shine light in this way, you'll see that the light comes out of all the mirrors. And the laser light, when they came out of the bar, or the laser diode array, as all the laser lights would come in this way, and they would shoot out this way. So in this direction and out. Okay, so here's a frosting optic, and you can see it has a little bit of a dichroic coating to it. So it appears to be on this side, and yeah. So that's just to disperse and even out the laser light just a little bit as it goes through, give it a little bit of a blur. That way it's not so harsh, doesn't have those laser patterns and stuff on it. Just a little blurring optic with a little bit of an anti-reflective coating. Here we go. Let's take a look at how the entire optical path worked. So first you have the Jacob's ladder mirror assembly, and all of the laser beams would come into here, get reflected off, and pass through this lens. Once it passed through that lens, it would then pass through this filter, which blurred it a little bit, and would enter in this area here. This is a negative meniscus lens, and it would widen out the laser light at that point. And the red LED that sat here came in and passed the light through this filter, and this lens reflected off into the assembly. And now we have the blue laser light, which gets passed through here, and the color wheel rotates in a manner like this. And when it's in an area that is a phosphorus coating area, the laser light will get reflected off back through this optic. This is a positive meniscus lens, and then bounced off here. The green light that comes from there then will come through this lens right here, and it will bounce off this object and go through here. When the color phosphorus wheel is here in the frosted section, the blue light will come through here, and it will bounce off this mirror instead of being reflected by the phosphorus coating, and the blue light will pass through these lenses and pass through here. Okay, and there's the DMD. That's the part that I want. Okay, here's the whole assembly now that takes in the light, and this is the zoom and focus mechanism on the inside. So that's got to be that front assembly and steerable by both of these stepper motors here. Start separating out the zoom assembly, which looks like it's just a couple of screws. So here's what happens. The combined light comes in here as it cycles red, green, and blue. It hits this first surface mirror here in the back. It gets sent into this lens. And there's a little mirror right there. So the light comes in, reflects off that mirror, and that hits the digital mirror device on the board. Let me pull that mirror up. So the digital mirror device rests here. So the light comes in, bounces off that mirror, hits the DLP chip right here, and the light is then projected off the DLP chip. Looks like we have two lenses, both the positive meniscus, positive power lenses, it looks like, and another positive power lens here. So it has a nice anti-reflective coating on it. So here's those four little mirrors in that little box, the first surface mirrors on the inside of there. And hold it up to the camera. You can see how it kind of collects everything there. Makes little trippy designs and stuff like that. Whee! But yeah, that's what that is. So there's also little springs in there. Okay, and looking up the DLP-A200 chip, I have found the 12-volt power rails, and now I can kind of connect it up. I didn't get it to do something, which is a step in the right direction, right? I think so. Let me show you what I've got it to do now. Negativo. Positivo. Yeah. It's not much, but it does mean that I can put this under the microscope.
The term DLP often covers two types of technologies, the digital mirror device shown here and the liquid crystal on silicon, which is a hybrid between the DLP and the LCD technologies. These are micromirrors. Each one of these little mirrors physically tilts. That's amazing.
Let's go over the boards that are in the projector. First, starting with the power supply, and it's a fairly straightforward power supply. So AC mains air, 120 volts, and a couple of the ceramic capacitors, common mode filter suppressor, the capacitor fuse. Looks like we have two metal oxide resistors, another filtering capacitor, the full bridge rectifier here, another filtering component. This could be an inductor or transformer. This looks to be the transformer for the standby voltage for triggering the power supply, or like a 3.3 volt feed or something. You got the high voltage capacitors. I believe these are both 400 volts. Yeah, 400 volts. Makes perfect sense. And the switching transistors for the bigger transformer here. That's a pretty nice transformer. On this side, we have a couple of things. We have the smoothing capacitors for the outside, or output on the low side. And we have, I believe, either like 36 volts, 24 volts coming out of here. I haven't tested it yet, but it looks to be just two tied. These are all tied together, and these are all tied together. Looks like there's another pin there, probably for like feedback or something, turning it on. And the same thing here, we have a 5 volt and a 12 volt reference here with another turn on connection. I believe that's a turn on connection. Very nice power supply. Take a look at the other board. So the power supply connects up to this board. This board does a couple of things. First, it gets the power in through these connections right here from the bigger transformer, and I'll notice there's a couple of the power supplies here, switch mode power supplies. You can tell the inductors and the MOSFETs and the rows of capacitors here. It's probably going to be a buck mode power supply for driving the laser diodes and the power supply for driving the thermoelectric cooler, as well as the LEDs. So I got this ribbon cable right here, which connects to the main logic board, motherboard of the projector. This ribbon, sorry, not ribbon cable, this connection right here that connects to the red LEDs, and it does look like those two last wires here are reserved for sensors. This is the thermoelectric cooler, so the voltage for running the filter junction, thermoelectric junction, comes from there. And then where I stripped off the serial insertion force connector to try to hack into the sensors here. This is where the laser diodes and the laser diode sensors for thermal connectivity connect to. I found that it actually about a 10K resistor that you put in there to trigger it. However, the assembly altogether really isn't good to me. I just want the DLP core. So let's get on to the main logic board now. So we have a couple of things here, just for like running the color wheel, other like decoders and stuff like that. A lot of these are decoders for different applications like the HDMI, VGA, things like that. We got all these different decoder boards. And here's one for the HDMI, and then the interface where the micromirror assembly attaches to the actual micromirror driver and the digital micromirror itself. It connects to this chip right here, which I believe is the DLP-C200 chip, which controls the signals, basically routed through everything, and is where, you know, it's the CPU basically for the whole machine. And the DLP-C talks to the DLP-A chip, which is that little guy right here. So there's a couple of data bus lines that come through. Let's see, on this side, you can see where those serial data bus lines come in through here and feed into here. I think the rest of this is mostly for just power and stuff like that as well. And then here we have the, as I said, the DLPA, the little boost driver for the higher voltage for feeding the electrostatics into the mirror, and the actual digital mirror device. I think this is the DMD 5500. Not quite sure. I'd still love to get one of these running. I mean, they're amazing devices. Let's take a look at the LED. Okay, so here's the red LED. I'm not sure exactly what the full power of this LED is, just being honest. But we're going to hook it up and we're going to play around with it anyway. And I'll pop it underneath the microscope and we'll take a good look at how this LED looks at a high level of magnification. Things are better when magnified. Alright, so we got the LED turned on, and it's about 2 volts right now, drawing 0.4 amps. I'm going to turn it up to 2.4, drawing 5 amps. So it's drawing 5 amps right there. It's a pretty bright LED. It really is a pretty bright LED. Take a look at it over there. See how bright that LED really is. I mean, the entire workbench lights up when I sweep that over.
If you made it this far in the video, I would like to give you a thank you, and I hope that you've learned something about the DLP projectors. Unfortunately, at this point, I don't really have much more to show you because I don't have a functioning DMD or liquid crystal on silicon device, so my experiments are limited. I hope to get a fully functioning development board with a digital mirror device to do more experiments on in the future. Until then, stay tuned for more videos on optics and electronics.